Okay, so the first three problems, first three problems have distinct linear factors. So what you're going to do is you are going to factor the denominator first. So here you can factor out an x. So you get x times x plus 1. And what we do is we have two simpler fractions where we take each factor, make that the denominator, and then have these constants a and b, which we have to determine so this works out. So it's kind of deconstructing it and then figuring out what a and b need to be, so when we construct it back together we get the original expression. So now we're going to combine these two back again. So you're going to cross multiply because you have two of them. So you have a times x plus 1 plus b times x, all divided by the product of the two. And now you can see that both sides now have a common denominator, so we can set the numerators equal to each other. And because we have two unknowns, a and b, but we also have constant terms and linear terms, we can get two equations out of this, two equations and two unknowns. So, over here we have 0x plus 1. And if we well, in this case we don't multiply it out. What we do is we choose x judiciously. Okay, and we choose the x so each one of these terms over here go to 0. So the first one, if we set x equal to -1, that'll make that disappear. And if we set x equal to 0, that'll cause the second thing to go to 0. So we set, you'll notice x doesn't affect anything that's on the right hand side, but so because there's 0 x's. So we just always have, in this case, we have just 1 on the left hand side. So we get a times -1 plus 1 plus b times -1. So those are going in for x. You can see this goes to 0. So we're left with what we're left with is 1 is equal to -b, or b equals -1. So that's the first thing that we find out. The second part is where we let x equals 0. So I'm just going to do this separately. So you plug x equals 0 in here, so you get 1 is equal to a times 0 plus 1 plus b times 0. Okay, that term goes out. So we're left with a is equal to 1 is equal to a, or a is equal to 1. And so our original fraction, 1 over x times x plus 1, is equal to, okay, well we had a over, what did we have? We had a over x. So a is 1 over x. And then we had plus b, but b is -1, so it's going to be -1 over x plus 1. And you can check these things if you now, with a and b plugged in there, then you combine the two. So you'd have 1 times x plus 1 minus 1 times x, all divided by x times x plus 1. And you'll see the x's cancel out. We're just left with 1 over x times x plus 1, which is what we started with right here. So we won't do that for all of them. We'll just do it for that one. Okay, next one. So you're going to have, this is number 2. So you have 5 divided by, let's factor the denominator. So what do two numbers multiplied together give you? 6, 1 or 6, 2 or 3, 2 and 3. the difference between them is between 2 and 3 is 1. So it's going to be 2 and 3. And because we have the positive x here, the positive goes with the larger of the two. Okay, so what we're going to have is a over the first linear factor plus b over the second linear factor, like that. So again, we want to combine these two. So we get a times x plus 3 plus b times x minus 2, all divided by x minus 2 times x plus 3. And you see we have the same stuff, same denominator now, so we can set the numerators equal to each other. Again, we're going to choose x to be two values. So we're going to let x, first x is going to be equal to negative 3, so this term will go to 0 when we do that. And we'll let x equal positive 2, that'll make that go to 0. So doing the first one, we have 5 is equal to a times negative 3 plus 3 plus b times negative 3 minus 2. Again, plugging in. Over here we have 5 is equal to a times 2 plus 3 plus b. Let me move this thing over a little bit. So we have a times 2 plus 3 plus b times 2 minus 2. Okay, so this one goes to 0 over here. This one goes to 0 over there. So we got 5 is equal to negative 5b. And here we have 5 is equal to 5a. So we get b is negative 1. A is equal to positive 1. Just turns out that's what it was last time, but that doesn't have to be that way. So we can now plug those values into here. So the answer is going to be 1 over x minus 1 minus 1 over x plus 3. So that's the partial fraction. And remember, the whole idea, the reason we do this is because if we're doing calculus, to integrate this first term is difficult. To do the two other terms is somewhat trivial. Maybe I shouldn't call it trivial, but okay. Number 3. So we've got x plus 2 over x times x minus 4. So here we've already got it factored. Even though we have x plus 2 in the numerator, that doesn't matter. What matters is that we have two linear factors in the denominator. Okay, so you cross multiply a times x minus 4 plus b times x, all divided by x times x minus 4. On the left-hand side, we've got the same denominator, so we can set the numerators equal to each other. Like that. And again, because they're two distinct linear factors, we're going to choose x. So we're going to let x equal 4, which will make that go to 0. And we'll let x equal 0, which makes that go to 0. So what we have is, in this case, I do have to plug something in on the left-hand side. So we'll have 4 plus 2. 4 plus 2 is equal to a times 0. I'm just going to plug it in there. 4 times 4 minus 4 is 0. Plus b times 4. So you'll get 6 is equal to 4b. B is equal to 6/4 or 3/2. And then a, we have 0 plus 2 is equal to a times 0 minus 4 plus b times 0. So this second term goes out. So on the left-hand side we have 2. On the right-hand side we have negative 4a. Negative 4 times a. So you get a is equal to negative 2 over 4, which is negative 1/2. So now you can see the final answers. We have a, which is negative 1/2. So put -1, and we'll put a 2 in the denominator. So there's the -1/2, and there's the x in the denominator. And then you have b, which is 3/2. So what we'll do is 3 over 2 times x minus 4. Now let's just double check this one. So if we want to put this back together, you'd have this times that. Well, let's switch the order just because I'm used to, if you have a subtraction here, I know what to do. All done is switch the first and second. Let's see, let's factor out a half before we combine the two. So you get 3 over x minus 4 minus 1 over x. So I've just factored out this 2 that's in the denominator. Okay, now let's cross multiply. So there, what happens is you have 3x minus x minus 4, all divided by x times x minus 4. And we have 3x minus 1x, so that'll be, we get 2x, and then negative and negative, so it's 2x plus 4 over x times x minus 4. And you see you got a half in the denominator, so that's going to be x plus 2. So I divide each of these by 2. So you get x times x minus 4. And hopefully that's what we had to start with, which is what we had, x plus 2 in the numerator. So that did work. Okay, number 4, this is what we would call repeat linear factors. And let's put let's add the page. But first let's get rid of that one page. So the last one is a repeat linear factor. So in that case, what you do is you take one of the linear factors, put that over a, and then you have b over x minus 3 quantity squared. So this is the second denominator is the same as that denominator. Okay, so we go through the same procedure, except we can't cross multiply because we already have x minus 3 squared. So what we do is we multiply this term by x minus 3, and the second term we don't do anything with. And then we have x minus 3 squared. So by multiplying the numerator and the denominator by x minus 3, the denominator becomes x minus 3 squared. And now we're back to the same situations. We have the same numerators, so we'll have 3x is equal to a times x minus 3 plus b. So you can choose two values of x, but one of the values of x is 0. So what we'll do is we'll choose x equal to 3. That'll make that go to 0, and we can solve for b. And then we'll choose x equals 0. And then we can use the value for b that we've calculated then to calculate a. Okay, so let's plug in x equals 3. So we get 3 times 3 is equal to a times 3 minus 3 plus b. So you can see what happens here. This goes to 0, and you get b is equal to 6. Now over here we have 3 times 0, and that's one of the reasons we choose 0, because that term goes out. And so then you have a times 0 minus 3 plus b, but b is 6 from this previous step. So you'll get 3 times 0 is 0. A times negative 3 is negative 3a. And then we have the plus 6, so that it's negative 6. 6 goes to the other side, becomes negative. You divide by negative 3, so you get negative 6 divided by negative 3, which is 2. And then you take those two values that you just calculated. A is 3 and b is 6. And Actually, A is 2. I don't know where I got 3 from. A is 2. And B is 6. Okay. And the next group are quadratic stuff with quadratics. So number 5, we have a linear factor and a quadratic factor. So when that happens, quadratic factors you don't just have a single constant. In the numerator you have bx plus c, and that's all divided by the quadratic term. And these are, quadratic terms, there are no real roots. So if you solve for x, you get plus or minus I. So that's why we don't factor it any further, because we can't and get real values. But we can do our little cross multiply thing here because we've got two fractions. So you'd have a times x squared plus 1 plus x times b squared bx plus c all over x times x squared plus 1. And then we've got the same thing on the left-hand side. So this times that plus that times that. So what you do again is set the two numerators equal to each other. And one thing, once you have quadratic factors, we have to do something different. So we're going to multiply out the quadratic factors. Or these factors. So you're going to have a times x squared. You'll have a times 1. And on the second one, we'll have b times x squared, bx times x, and then we'll have c times x. And then you can combine the two, combining like terms. So you'll have a plus b, both of those times x squared. You'll have plus cx and plus a. We kind of put it in the order of x squared, x, and constants. And then what you do is you group the x squared terms, actually the coefficients in front of the x squared terms. So you see the coefficient in front of the left-hand side is 1, and then the right-hand side is a plus b. So those are the x squared things. Then you have the x terms. So here we have negative 1x, so we just do the negative 1. And on the right-hand side we have cx, negative 1, x, cx. And then we have the constants, and there are no constants on the left-hand side, and there's one constant on the right-hand side. So in this case, we have our first constant. A is equal to 0. Which bothers me. Because then we don't have that term. So what does that mean? So it might mean I did something wrong. Ah, yes. So I think what I'm going to do, well, yeah. So you're gonna be like, why did you do this to me? So the problem here is if I factored out an x here, I could cancel the x's out. So that's why it does it. So what we're going to do is we're going to redo the problem. We're going to put a negative 1 here. That might have just been my error. So what that is, it'll make this negative 1 here. And that'll make that negative 1 there. So we have x squared minus 1. Okay, so once we fix the left-hand side, we still have the x squared terms still are 1 is equal to a plus b. In the second case, we have c is equal to 0 because there are now no x terms. And then we have that negative 1 is equal to a, or a is equal to negative 1. So that's our new answer, now that I've made that. We also have c is equal to 0. And then you can substitute this in here. So you get 1 is equal to negative 1 plus b, using this known value of a now. So you get b is equal to 2. So that's the third thing. So what we can do is we can take the original modified expression and plug in negative 1 for a, so we get negative 1 over x plus bx plus c. So we said b was equal to 2, so you get 2x plus c, which is 0, divided by x squared plus 1. And then we could get rid of that 0. Okay. Number 6. Okay, well, this is not factored, so the first thing you gotta do is factor it. And probably when we factor it, we'll end up with a quadratic term that we can't factor any further. That's probably why it's in there. So we take the coefficients of the denominator, and we're going to guess. Okay, so I'm going to guess 1. So 1, bring that down. 1 times 1 is 1. Negative 3 plus 1 is negative 2. Negative 2 times 1 is negative 2. Add these together, you get negative 6. 1 times negative 6 is negative 6, and so you get 6. Okay, so that didn't work. So it looks like 2 might work. So let's try 2. Why do I think 2? Because it seems like things that get doubled there, so let's try 2. Okay, bring the 1 down. 2 times 1 is 2. Maybe not. Maybe it's not going to work. Maybe it should be negative 1. Let's finish this one up. So you add these two together, multiply, you get, no, maybe this is going to work. Okay, 2 times negative 1 is negative 2. Add these together, you get negative 6. 2 times negative 6 is negative 12. You get 0. And, well, so we have one factor, which is x minus 2. And what we have left is x squared minus x minus 6. So you can actually factor that. See, x minus 2 times. So here, two numbers multiplied together give us negative 6, which is 2 and 3. And so we're going to have negative x minus 3 and x plus 2. So the you can see if I multiply these out, I'll get negative 3x plus 2x, which gives me negative 1x. So this is an example of the case where you have 3 linear factors. So it's just a little bit more work. So we're going to have a over x minus 3 plus b over x minus 3 plus c over x plus 2. Now, one thing's good is we are going to be able to solve this reasonably easily once we get it all together, because we can set each x equal to 2, 3, and negative 2, and it'll simplify things considerably. But so what we do now is we take a times these two, take b times those two, and c times those two. So we'll have a times x minus 3 times x plus 2 plus b times x minus 2 times x plus 2 and c times x minus 2 times x minus 3. Now you may be tempted to multiply all that out. And remember, this is equal to x plus 6. But it's better if we choose x equal to 3, x equal to negative 2. Actually, well, let's choose let's choose the ones that, I mean, we can paste on this. X equals 2, X equals 3, X equals -2. And what that's going to do is, if we stick +2 in, these two are going to disappear. So from the first choice, we'll get 2 plus 6. So I'm doing this one first. 2 plus 6. 2 plus 6 is equal to just this thing. So you'll have A times 2 minus 3, 2 plus 2. So we'll just go ahead and finish this out. So you get 8. Here we have -1 times, so 2 minus 3 is -1. -1 times 4, so you get -4. Divide by -4, you'll get -2. Okay, so that's A. The next one is we're going to let x equal 3. What that'll do is get rid of this first term and the last term. So you have 3 plus 6, 3 plus 6, these go out. We're just left with the B thing. So you have 3 minus 2 and 3 plus 2. So 3 plus 6 is 9. 3 minus 2 is 1. 1 times 3 plus 2 is 5, so you get 5b. B is equal to 9/5. So that's the second thing. And then you'll choose this one. That'll make this go to 0 and this go to 0. So you get x, which is -2, plus 6. So you get s plus 6. Like I said, these two drop out. The only thing we're left with is c. So you get -2 minus 2, -2 minus 3. So over here we get 4. So you have -4 times -5. So that's positive 20. So you get 20c. Okay, so this is -4, this is -5. -4 times -5 is 20. So c is equal to 4 over 20, which is equal to 1/5. So those are my 3 values, and then you can plug those in to the original expression that we used to do this whole thing, which was, where was it? Oh, somewhere here. There it is. That's what we're looking for. So that's the expression. So now I just need to plug in what I know. So a is -2, so you get -2 over x minus 2. B is 9/5 plus 9 over 5 times x minus 3, and 1/5, so you get plus 1 over 5 times x plus 2. There's your answer. Again, one way you could check this out. So since I could have made many mistakes here, I could plot my original function, my original rational function, which is this one. So let's do that. And then we'll plot the second one, which is the modified one. We'll see what they look, if they match up. So cross your fingers here. Let's see if I got this right. Okay, so the first one was 6 divided by x cubed. X cubed. I forget some x. I can't see right now, so I'll have to come back and do this again. X squared minus 4x. Plus 12. Okay, that's not exactly right, but I need to enter it in here. So let's, okay, x cubed minus 3x squared. Okay. X cubed minus 3x squared minus 4x plus 12. Okay, Okay, so we're going to graph that. So that's what it looks like. And then I could plot my partial fraction one here. So I've got -2 divided by x minus 2 plus 9 divided by 5 times x minus 3 plus 1 divided by 5 times x plus 2. Let's just check that out. -2 over x minus 2 plus 9 over 5 times. Okay, and I graph that. Ooh, it's close. It's not quite right. So let's go back and see if I just wrote something down wrong. Or if, let me check my functions first here. X cubed minus 3x squared minus 4x plus 12. X cubed minus 3x minus 4. Okay, so that looks right. Let's look at the next one. -2 over x minus 2 plus 9/5 x minus 3 plus 1/5 x plus 2. Okay. Make sure I wrote these, copied these down right. Okay, so that looks right. Okay, let's go back and check these out here again. So -1 times 4 is -4. So that looks right. Then we do the next one, which is x equal to 3. So that goes to 0, that goes to 0. You got 3 plus 6 is equal to b times 3 minus 2 times 3 plus 2. So that's 1 times 5, so that's right. 9/5, okay, that looks right. And the last one is -2, which makes this go to 0 and this go to 0. So I have -2 plus 6, which is 4. I have -2 minus 2, which is -4. -2 minus 3, which is -5. So that's -4 times -5, which is positive 20. Divide that out. Divide by 4. So that looks right. I don't know. So let me pause this and think about it. Okay, so I figured it out. I forgot the x. So let me just go back here and just put x plus 6 in this numerator, x plus 6. And now we'll graph them. And you see they are the same thing. Okay, so that worked out good. What I did is I went online and put the original expression in there and solved it where it went wrong. Okay, let's work on problem number 7. So this is another example of a linear and a quadratic factor. So what we're going to do here is we're going to take 2x plus 4 divided by x minus 2 times x squared plus 4. And so for the linear factor, we just have a constant a that we have to determine. For the quadratic factor, we have to have a bx plus c, all divided by x squared plus 4. Okay. So since we got two terms here, we can cross multiply. So you're going to have a times x squared plus 4, and then you'll have x minus 2 times bx plus c, all divided by x minus 2 times x squared plus 4. And we got the same denominator on the left-hand side. So as usual, we set the numerators equal to each other. And when you have a quadratic factor, you always have to use the second technique, which is to match up all the x squared terms, coefficients, and all the x terms, coefficients, and all the constants. So over here is implied 0x squared. So before we can do that, though, we're going to multiply, get rid of all these parentheses. So we're going to have 0x squared plus 2x plus 4. So we'll get ax squared plus 4a. So a times that is ax squared. 4a, I don't do it as a4 because it's just better to put the coefficient first. I mean, yeah, put the number first and the variable second. Okay, the second part we use FOIL, so you've got bx times x, which is bx squared. Then you have, let's see, FO. So then we have cx, and then you got a negative sign for the next one. So you got x times c. Then you've got negative 2 times b times x, negative 2bx. So that's inner, and then we have last, which is negative 2c. And then we can regroup the stuff on the right-hand side. So put all the x squared things together. So you got x squared times a plus b. So ax squared, bx squared. Then you'll have the x terms, plus x times, so we have c minus 2b. And then the constant terms, we have 4a and negative 2c. So that's all algebra. Then we can write out what we have. We have the x squared part, the x part, the constant part. So you'd see on the left-hand side we have 0x squared. On the right-hand side we have a plus b. That's right there. For x we have 2x. So that's equal to c minus 2b. And then we have the constant 4 on the left-hand side and 4a minus 2c. So we have 3 equations and 3 unknowns, but luckily it's not that hard. What we're going to do, and the procedure you would use, is we're going to use this one to rewrite this. Instead of an a and c, we're going to write it in terms of b. So how do you do that? Well, you take the first equation, solve for a in terms of b. So you'll subtract b from both sides. Here we're going to solve for c. So if we take negative 2b over to the other side, it becomes plus 2b. So we're just rearranging these, solving for a and for c, both in terms of b. So now we can plug it into the third equation. So we have 4 equals 4 times a, which is negative b, minus 2 times c, which is 2 plus 2b. So what do we get? We get 4 is equal to negative 4b minus 4 minus 4b. Okay, negative 2 times 2 is negative 4. Negative 2 times 2 is negative 4. So if we add 4 to both sides, we'll get 8. And if we have negative 4 plus negative 4 is negative 8. So that gives you that. So b is equal to negative 1. So that's the first thing we do. Then you can use that b up here to find the other two. So a is negative b. So since b is negative 1, a is 1. And then c is equal to 2 plus 2 times b. b is negative 1. So that's equal to c is equal to 0. So now we can rewrite our expression. So our original expression, which was 2x plus 4. What we'll do is we'll just grab that. So I don't have to recopy this thing. We'll copy it. Copy. We'll go to the end here. Paste. Oh, that's not paste. Where's paste? There's paste. Okay. So this is going to be equal to a, which is 1. over x minus 2 plus b, which is negative 1 times x over x squared plus 4, or 1 over x minus 2 minus x over x squared plus 4. So again, what I'm going to do is I'm going to plot these two because they're the same. It's the same, two ways of doing the same thing. So the first expression is, I've already forgotten what it is here now. I can't see it. Hold on just a second. Let's shrink this up a little bit. There we go. All we're doing here is looking for, they're the same. So we have x plus 4. I'm going to put those in parentheses. X plus 4 divided by x minus 2. And let's just put two parentheses here. Okay, x minus 2 times x squared plus 4. Okay, let's just graph that and see what it looks like. So there you go. Let's zoom out a little bit, see if there's anything else going on. No, that makes sense because we've just got one vertical asymptote. We have a y-intercept of something here, small number. Okay, and then we have this, the partial fraction version of this whole thing. So it's 1 over x minus 2 minus x divided by x squared plus 4. Graph. Cross my fingers. Oh no, I messed up again. What did I do? Rats. You're like, you can't even get it right. What is the problem? Yeah, it's pretty darn close, so it's got to be a small error. Oh, it's 2x. It's because I keep hiding my equation. I did that last time too. 2x plus 4. Not x plus 4. Now if I graph them, they're the same thing. Okay. So I didn't make a mistake either time. Okay, so that's the way it works. So let's review what we did here. So we took the linear term and the quadratic term. Linear term, we had a as a constant. For the quadratic term, we had bx plus c. You cross multiply these to get the common denominator. That's the same as the left-hand side. We set the numerators equal to each other. We multiply everything out. So, and then we group the terms that are associated with x squared, x, and the constants. And then we set the constants equal to each other associated with the three different terms. So we had 0 equals a plus b. From x squared, we had 2 is equal to c minus 2b. And we had 4 is equal to 4a minus 2c. Then the last equation is a function of a and c. So you solve first equation for a and the second equation for c. And because there's only two variables here, what it's solved in terms of is b. So when I make the substitution, which was originally just a function of a and c, when you make the substitutions, it becomes just a function of a b. So you solve for b, and once you have b, you can go back to these two substitution equations used to find a and c. And then you just insert those into your original partial fraction expression. Okay, so we have one more, I think. Yeah. So the last one is this. The last one is this double roots for the squared part. So we're going to end up with x squared plus x plus 2 divided by x squared plus 2 squared. So it's kind of the same thing that we did for repeat linear factors, except we're going to have a plus bx here over the quadratic term, and then you're going to have should have done AX. Let's use AX plus B, and then we'll have CX plus D. I mean, it doesn't really matter. Over this thing squared. Now to find, it may look more difficult than it is, because what we're going to do is, this one already has the right denominator. This one needs to be multiplied by x squared plus 2 again. So in the numerator we're going to have ax plus b, and we're going to multiply that by x squared plus 2, whereas the second part is just cx plus d, because we already have the appropriate denominator. And again, these denominators are now the same, so I can set the numerators equal to each other. So I'll have x squared plus x plus 2 is equal to ax plus b times x squared plus 2 plus cx plus d. Now again, you're like, oh, I got 4 constants I gotta solve for. And you know, if there was an x cubed term, then it probably would be a little more difficult. But because there's no x cubed term, it's not as daunting as it may seem. So we're going to multiply out this using FOIL again. So first is going to be ax cubed, so ax times x squared. Then we'll have, I'm going to go ahead and do the inner, because that's a higher order, so you get bx squared. Outer is 2ax, and the last is 2b. We're going to add to that cx plus d. So we're going to have the x cubed terms. Well, there's only one of those, ax cubed. We only have an x squared term, so that's easy. Then we have the x term, so we have 2a plus c, 2a plus c, and then the constant bit is 2b plus d. And again, there's 0 x cubes. So setting the x cubed equal to each other, coefficients, you'll have 0 is equal to a, or a is equal to 0. Okay. X squared, we have 1 is equal to b, or b is equal to 1. Okay, let's do the x terms here, because that way we can see everything. So you have a coefficient of 1 on the left-hand side, and we have 2a plus c, and the constant, we have a 2. 2 is equal to 2b plus d. So 2 is equal to that. And so because a is 0 and b is 1, then we could put 0 in here for a, for the x part. So we get c is equal to 1. And then the last one, you get 2 is equal to 2 times b. b is 1 plus d. So you get d is equal to 0. So we really end up with only 2 terms here. Remember, it was ax plus b and cx plus d. This one was over x. What was the quadratic term? X squared plus 2. X squared plus 2. This is over x squared plus 2 squared. So with a equal to 0, we'll have b, which is 1, divided by x squared plus 2. And c is equal to 1, so we'll have c 1 times x. So we'll have x over d is 0. So we get x over x squared plus 2 squared. And the advantage is that in the numerator here we have just x and a constant. We don't have x squared. So it may not seem that much simpler, but again, in calculus we can integrate these things a lot easier than the original expression. So again, we're going to plot these two do you have to do this? No, this is just a way of me checking to make sure I got the right answer. And it just demonstrates that there's nothing, they're the same expression. So the first one is x squared plus x plus 2 divided by x squared plus 2 quantity squared. Okay, let's see what that looks like. So there it is. And then we will go to the answer, which is right there, and move this out of the way. So I'll put in the answer I got. Hopefully this, well, actually I didn't go far enough. Where is it? Where is my answer? Oh, it's down here. There we go. Okay, so we get 1 divided by x squared plus 2 plus x divided by x squared plus 2 quantity squared. And there you go. See, they're the same thing. So that's it. You know, what kind of problems might you get on the test? Most likely you're going to get one where you have distinct linear factors. So we go back to the original, and just 2 distinct linear factors. So like problem 2, like problem 3, and problem 1, 2. 1, 2, and 3. So that's the ones most likely. And then there'll probably be one that has a linear factor and a quadratic factor. So that is somewhere, I think I must have sped by it here. Oh, here we go. So like 5 or 7. 3, this one here has 3 distinct linear factors. That's probably not going to be put on the test. Repeat quadratic and repeat linear factors. Probably not on the test.